Welcome everybody. I hope you can hear me well. Today is our fifth session, so I'm very happy that we are doing this and we are going far. And today we are going to talk about downsampling and query performance. The query performance will be very open. We can talk about it in the questions, but the overall idea is about downsampling today, and that's something that really impacts the performance. Okay. So moving on, just a reminder why we are doing this. This is a call to action as a community manager that we want to organize finance stuff, and especially want to organize some common broad scripts that everybody can use. So the idea is like, maybe we are going to define some industry standards. Maybe everybody's doing something similar. And as the folks that are storing the data on Timescale, then they can also share these type of scripts. So today is the fifth session. Yesterday we had the second session on the sensors data, and we are trying to also organize it through different industries. So that's a work in progress that we have here. And yeah, so the next session will be about compression, and the previous session was about tracking pair correlation. So we had several sessions already. Everything is on YouTube. If you wanted to check something else from this list, you can also find this. And let's get started. So we have this GitHub timescale templates. So, and the actual template for finance is done. So this is only for market data stream. And what we have here is this small, very simple ticks table that only stores trades, and then we create a hyper table out of it. So we partition data every 1 day, and then we also enable compression after 1 week, and we make it as a compression policy, right? Then we introduce the hierarchical continuous aggregates that allows you to roll up previous calculus, and it allows you to speed up your database. And today we are going to talk about downsampling, especially LTTB and ASAP smooth algorithms. So these are two things, and let's start with the methodology. So we have downsampling as a concept that means like you are reducing your data into some other level of granularity. And if you think about continuous aggregates, it's also a type of downsampling method. But today we are going to talk about algorithms that can go to raw data and still downsample, or can go to summarize the data and still downsample it. So, and the next week we are going to talk about data retention. That's another way of downsampling your data. You need to recycle some of it and also remove it in somehow, right? So let's just review a few advantages. So first thing is memory efficient. So when you are downsampling, you are sub-selecting elements from your entire set, and that will just make a smaller memory footprint. So it will also improve the throughput because you are having smaller packages in general. So your I/O will be using less and less. Network will also be being optimized by this. So when you are downsampling things, basically you are sending less data from your server to the client. You are sending less data between your disk to the memory. So downsampling, using these methods, we are downsampling between memory and directly disk access. We are not going into a programming language layer or serializing, deserializing packages of things into memory level. So serialization and deserialization is also very important. So if you are, for example, using an ORM like an object relational mapper, or something that you work with lists of objects, for example, and your objects are complex objects with like possible, let's say, scenarios that you have as a good way from the business model, but these all consume more memory when you are loading. So if you are loading more data, you have more of this deserialization when it arrives from the network package to the programming language, and serialization when you get it from disk to a package. So you need to transform it into a network package, go through the machine, and then come back. So this is how a trade that you need to choose where you are going to do this. So sometimes, for example, you just do downsampling on the front end. So you serialize everything, and then in the last moment, just for showing the user the screen, you do the downsampling to just have less data points in the screen and make it more visible. So that's the idea. You can do it in the database side, right? And in the end, you have faster queries. And better than that, you have also predictable performance because you know exactly how much memory footprint you are going to have in each call. If you know, like, hey, this is a query which I'm going to fetch 10 or 100 rows to represent this data. So it will not go far from these 100 rows, and it will keep like a small buffer and a way that you can make it, let's say, controllable in terms of size. So in the end, it will end up as cost savings. You not pay too much. You end up like having a good cost savings. Downsampling also has its own disadvantages. So let's just recap. What are the main disadvantages? Precision loss. So if you need high precision, maybe it will obscure important information. And also risk of misinterpretation. So maybe you end up with a bias algorithm or something because it's not like looking the entire data set, right? And maybe it's too complex to choose what's the proper method for adopting for your downsampling. Is it better to store the mins and max and the average, or is it better to just start a histogram? What type of storage and what type of mathematical model do you need for your data analysis? So this can lead to some complexity. So what if I cannot downsample? Maybe I cannot downsample. Maybe I need to leave, and I have a very high frequency data, very dense data. That would be very expensive. In this case, you can think about storing it somewhere else, like maybe Postgres will be too expensive for very cold data, like you just need some place to leave your data that and audit. And one alternative is use like Postgres FDW, like you can just write something and store your files on Parquet files, make a combination of this type of tooling, and then you can just like leave it there. If you are looking for a already done solution, Timescale Cloud contains a technology named tiered storage, and that's the idea. So you start with your regular cycle, which you just process your data and compress it, and then after compressing, you can also add a tier. So you can just add a tiering policy, and then your data will be moving to S3 automatically. You can still query data from there, and you can do everything transparently, but you have access to this cheaper storage. This is Timescale Cloud only, but this is a very cool technology. Give it a try. The Timescale produces several different technologies, and we are investing a lot on our cloud. And this is one of the amazing features we have. It's not open source because making it open source would be another trade, another effort. So we just decided to start with the cloud to just increase the speed we can advance in this tool and offer the users a very nice mechanism to store their data. And here is our project example. So today, this is crypto data. I'm going to show today crypto data because I found a real-time server. We are storing crypto data from 12 data for free. And I'm going to use this. So this is an example of BTC. This is the data that we have. And I'm going to show you this, that is the infinite zoom tutorial. this comes from my Ruby background. I am the creator of the TimescaleDB gem. And if you're not familiar with TimescaleDB in programming language, some folks just created a good integration with this. I'm just judging good because I did it, but it's a code that you can give a try, and you can see if this makes sense for you, right? So this is the way that you define a model in the Ruby ecosystem, or inheriting active record base, which contains, let's say, everything that means this is a model related to a table. And in the active record ecosystem, they have a lot of acts as blah, blah, blah. So you can incorporate your macros into the Ruby and inject your code using acts as. So I put 2 acts as there. So these are just to make it very easy to introduce shortcuts and use this. So let's walk through this. So when I receive a request from the web, I can just see if someone is selecting a small part of the filter. And then when they select, I just parse what time they have. And by default, we are looking to Bitcoin USD. Here, we are just exploring one as an example. I just built this like this week so it's not like a production ready code, but and here you can see our previous our scope being defined. So we say cryptoticks.where, and then we have this this small map showing what we want to filter. We want to filter by Bitcoin symbol and also by time, using a time between this or that. So if we don't filter by time, that's what we do. So in this case, we declare this method named scope, which we are going to use in the web request. So from this scope, we want to access the LTTB. So we'll just write the SQL part. I will show you how the SQL works. And then we have the threshold, how many records we want to have in this scope, right? So that's all the code. We just have in the front end the Plotly latest and some jQuery because I am not so proficient. And here is like the downsampling the entire code. So we have a combo in the top saying how much elements I would like to check from this, and if I change the threshold, I will change and get back the entire thing. And I'm going to downsample the entire database versus downsampling a small part, right? And you can see here we have some very small, let's say, some very small hook that we say when you do when you select a range, please hook this range and refilter it again and fetch the data again. So that's how it works. Let's see it in action. I think I have it open here, and here is it in action. So I can put here, for example, 50 records. It will start from scratch, and it will refresh the page with 50 points, right? For example, here you can see we started this tracking this database in 2022. So we have 2 years of data, and we have around 6 million, almost 7 million records here, right? So now I'm going to change here to get like 1,000 data points. And then it's just like filtering 1,000 data points from these 6 million data points. So imagine like fetching and traversing 6 million data points in the network. It would be very, very expensive. Here it was not that bad. So for example, let's say we want to study here from January until April, for example. Oops, I'm just trying to get it. And you can see that we get here from December, and then we still get 1,000 points. So this is what I call infinite zooming. It's like Google Maps. So you can just keep zooming. So for example, let's get here, for example, let's get here last 2 weeks, and we can still, it's refreshing, and then you can still get the same amount of points, and it's much better than you try to force your screen to load data that will not fit there. So Chen is raising the hand to talk. Chen, if you want to leave your question, I can also open the mic. Let me just wrap up the presentation and show the sequence of this part, and then we can go to questions and answers and see it. So this is a very small thing. If you want to check this and just to learn more, you can see this page, that's the TimescaleDB gem. You can see here zooming with high resolution with LTTB zoom. Here I explain exactly this. You can just walk through this code and learn how it was done. And I just adapted. So this is a very small sample to understand how it works. And now let's move on and let's see what else we have here. So we have LTTB and ASAP. So they have exactly the same syntax. So the syntax that you can see here, you just put the time, the price, and how many records you want from that thing. And then, for example, the symbol, you can leave it as a group by clause, for example. So you have this data. So let's jump into the terminal here, and let's take a look on some examples with the LTTB example here. So in this example, we are getting the 10 most important prices, let's say, from the last year on Bitcoin. So here is like a resume, like you are just getting the most important points, and how LTTB is different from ASAP. So if you see here, for example, here you can see this peak that is on the day 14th of March this year, and you can see 30,271. So if we do exactly the same thing, but instead of going to LTTB, we are going to go and do it with ASAP, smooth, and then you can see that it will change and it will use an average. So ASAP uses like an average and try to follow trends, while if you use LTTB, it tries to keep the orientation of our let's say visual appearance of your graphics. So it will keep all the peaks. So in this way, you can get averages versus the peaks, and you can understand how it works. So for example, you can see here it's 7 and 10, and the number here is 28,000 versus 30,000. So it's $2,000 difference and between one to the other, but they will just allow you to play in a different perspective with this downsampling mechanism, right? So that's one idea. And let's move on here. So here's the ASAP smooth that I was showing. And that's the explaining I did. So you will see smooth follows the trends, while LTTB preserves the visual appearance. So, and we also now have one experimental function about gap filling. So sometimes you lose data, so you have this gap fill in the middle, and you need to maintain it. So now we have the LTTB gap fill that will keep this and understand, well, data comes from here, and here is another slice, so it can do like multiple LTTBs and try to distribute this with the gap fillings in the middle. Other strategies, maybe like this is still not what you need. So another strategy here is histogram. So for example, histogram is a way that you can just create buckets to store amounts of data that you have into some specific place. So when you are doing histograms, you can just like get results like this. So for example, we are counting, and from the last day we have like 66,000 events from Ethereum USD, and you can see here the distribution if we count the price slices in 10 buckets. So you see most of it was in the highest bucket and a lowest bucket with something in the middle. Maybe if I get like, and zooming this 62,000 histogram, I can just generate another histogram and just go further on this. So you can split your data and get these volumes, understanding who belongs to what slice of your data. And that's one way. But we have several _egg, I always say, all the aggregation algorithms that the hyperfunctions occurs. So we have candlestick, we have percentiles, state aggregations, and so on. So all of them are also possible. So that's our ways of aggregating and ways of in the same way they can downsample things. So now we are open for questions. If anyone has any questions, feel free to comment in the chat or ask directly in the questions and answers. Okay, if we don't have questions, I just want to call you for the last session that is about compression and all kinds of side effects and things that you can learn with compression. And we are going to have this session next week. So I hope to see you next Thursday. And if you are excited about learning more, today, later in 1 hour, we have another session, 1 hour and a half from now. So about timescale vector with Lance Martin, that's also an engineer on LangChain. So I hope it's very exciting for you, as it's for me. Oh, we have a question from from Francesco. Just let me just come back here. So I will answer alive. The doc says that these functions are experimental. Only the LTTB, this gap fill LTTB is experimental, and this is experimental because we want to collect feedback from users, and we are going to stabilize it when we see that they are very reliable. So we have it with LTTB. LTTB was experimental in the past, and now it's not experimental. Maybe the docs from my own Ruby gem, they still refer to LTTB as experimental, but it was promoted as stabilized, I guess, more than a year ago already. So probably that's not more the case. Thanks for asking, Francesco. Okay, folks. And if anyone has any other questions, join our Slack, Discussion Finance Market Data, and the other discussions, like discussions on AI, LLM is also happening there. And I also offer office hours and join people. It's not the last webinar. This is the penultimate, and we have one next week too, Francesco. Thank you very much. Francesco was asking if that was the only last one or not, and yeah, that's not the last one. So, and we are going to also be promoting more office hours. Sorry, we are also going to promote more webinars and live sessions together with folks from the community. So, for example, I'm working with Nelson. We are trying to build some stuff, and probably we will also bring it to these sessions later. So stay tuned. Thank you again. Cheers. Bye.